Welcome to Science Geometry. Today we're going to talk about the law of sines. Note that we do not have a right triangle in this picture. This is a triangle, but it's not a right triangle. Up till now, we've only found angle measures and side lengths using SOHCAHTOA, and we've needed right angles. Right triangles are all similar if they have equal angle measures. But let's start with this triangle. We'll make a couple right triangles. We can just drop an altitude right there, and we can make it, we'll label it H, and we're going to make, so now I've got two right triangles, one here and one on this side, okay? So let's find the sine of each right triangle. If I look at A, I can find the sine of angle A, and that's going to equal the opposite side over the hypotenuse, H over B. And likewise, if I found the sine of angle B, that would be the opposite leg over the hypotenuse. It would be the sine of B is equal to H over A. So we've got a couple sines, and notice that they both have an H in them. So in the case of this relationship, I'm going to multiply both sides by B, and I've solved that for H. B times the sine of A equals H. I'll do the same thing on this side, only I'm going to multiply by A. And I end up with A times the sine of B equal to H. Now, since they both equal H, they equal each other, just like solving any system. So I can write B times the sine of A equals A times the sine of B. Just brought both of these down here. Now, we can turn that into a proportion very easily. If I multiply or divide both sides by A, side length A, it's gone from that side. By the same token, if I divide both sides by side length B, it's gone from that side. And I'm left with a real nice relationship. It's the law of sines that says the sine of any angle over the side length across from it equals the side of any other angle over the side length across from it in a triangle. So that's our law of sines. That's what we're going to be using today. You will see it written like this. The sine of A over A, meaning the angle on the side across from it, equals the sine of B over B, an angle. The angle always goes in where the sine is, and the side across from it. And C over C, it doesn't matter which angle and which side. So in words, the sine of an angle over the side across from it equals the sine of any other angle over the side across from it. So let's use that and find a side length first, a missing side length, and then we'll find a missing angle measure. Well, first thing I would do here is look and see that I have the angle measure 88, and it's across from sine, side, NP. So I can write the sine of 88 degrees is across from side length NP. That's the side I can find if I know another angle and the side across from it, which I do. See, we've got this 39-degree angle, and we know the side across from it. So they're in the same triangle, so these are proportional. The sine of 39 degrees over 22. So now I've got a proportion. I can solve it just like we did in Chapter 7. I'm going to write my cross products. NP, side NP, times the sine of 39 equals 22 times the sine of 88. Remember, the sine of 39 is a number, the sine of 88 is a number. Now to get side length NP alone, I divide by this number, the sine of 39. Those will cancel out. and I know NP is approximately equal to. We don't ever get exact answers here, folks. Well, very seldom. Now, if I want to work this out, I'm going to have to take, turn on my calculator, and the first thing I'm going to do is check the mode. And I want to look down here and make sure it's in degree mode, okay? And I see it is, so good. Quit that screen. And now I'm going to put this equation into my calculator, okay? I'm going to press 22 times the sine of 88 degrees, and then I'll press enter because that's the numerator, and I'm going to divide that by the sine of 39 degrees. I close my parentheses there, and that is my approximate length of NP. If I look at this 7, it's 5 or higher, so I'm going to call it 34.94 when I round it to the hundredth place. Okay, so that's how you find a side length. Real easy. Set up your proportion. Sine of an angle over the side across from it equals the sine of another angle over the side across from it. Write your cross product. Get your unknown quantity alone and just calculate the rest. Don't ever calculate to the end because you'll end up with rounding errors. Now let's look at this one. Let's find an angle measure. Start the same way. We have an angle, 75, and here's the side across from it. So I can write the sine of a 75-degree angle over 7, that's the side across from it, equals, and now I know this side, so I need to find the angle across from it. So it's going to be the sine of u over 5. This only works if you're finding the side across from the angle. So I can find the measure of angle u. I'm going to find the measure of angle u here. Okay? I'm going to do the same thing now. I'm going to set up my cross product. And I see 7 times the sine of u equals 5 times the sine of 75 degrees. I need the sine of u alone. So the opposite of multiplying by the sine of u is to divide. And I'll do that to both sides. And I know the sine of u equals, approximately equal to, and now we've got some calculations to do. 5 times the sine of 75 degrees divided by 7. Now this ratio is the ratio of the opposite leg to the hypotenuse. I can write it down. I'll just round it. You know, I'm looking at 7, so I rounded it from there. But I'm not going to take it out of my calculator because I need to find an angle measure. So the inverse sine of this, remember we use inverse sine to get angle measures. So that would cancel out, and on this side I just have the measure of angle u. And in my calculator, here's how we do this. We're going to say the second sine. Now there's my inverse sine, and I need this answer to go down here. So I'm going to press second and this negative sign, because you see down here above the negative sign is the answer. And that gives me all of this down there. So now I'm preserving accuracy. There's my angle measure. So I look at this, we always round our angles to the nearest degree, so 44 degrees. Okay? So when you're doing this, in both cases, whether you're finding an angle measure or a side length, set up your proportion. The sine of the angle over the side across from it. Get 2 of them. Find your cross product. Divide by whatever you have to get your unknown quantity alone. Once you've done that, in this case, if you're looking for side length, you just calculate it and you're done. If you're looking for angle measure, you have to take the inverse sine of whatever that ratio is, and then you get the angle measure. So one more step if you're looking for angle measure. So hopefully this helps. If not, talk to me in class and enjoy your Law of Sines.